All right, so we are talking about coordinate geometry. The topic. What's geometry? Hey, study of hmm? Angles. Yeah, study of shapes, basically. Study of shapes. So that's geometry, right? So, however, when we say coordinate geometry, it suggests to you that then there are other kind of geometry. Is that okay? What you know in primary, the basic level, is what the classical geometry is what we call Euclidean geometry. What did I say? Yeah, classical or Euclidean geometry. That one has to do with the study of shapes, like when you're learning perimeter, area, and those kind of things. The other forms of geometry that's a lot more advanced. Another one is, let's say, okay, yes, this somehow a kind of this also the same as Cartesian geometry. Like coordinate geometry, the same as Cartesian geometry. Cartesian that I can't really tell because but I know that has to do with a guy called Rene Descartes, right? So Rene Descartes, so Cartesian. You get the point? All right, so that's just by the way. So when we say coordinate geometry, it uses so you can write uses algebra and the coordinate system. It uses algebra and then the coordinate system to study geometry. It uses algebra and the coordinate system to study geometry. There's another one called differential geometry, where we are using calculus to talk about shapes and all the other things related to it. Yes. It uses algebra and coordinate system to study geometry. So algebra and coordinate system to study geometry. And the first thing we would want to talk about here is a distance between 2 points. If we have a point in a coordinate system, yeah, so we have two coordinates, one here, another one there, and then we join them together. I want to find the distance between these 2 points. Let's take this to be x1, y1, this point A and then point B. And this is x2, y2. So point A and then point B. If you want to find the distance between these 2 points, what we can also do is to just by extension think of this as a what? As a triangle, right? And if it's a triangle, if we have to find the side of a triangle, what concept do we use? What concept? Start with a P. Pythagoras theorem. Yeah. So if I'm looking for this point from here to here, I can find the base and then the height, right? The length of the base and then the length of the height. Is that okay? Now, if this point is x2, y2, what would this coordinate? Let me bring another coordinate c. What would the coordinates of this part be? Deriving it from this and this will be what? x2, y1. Perfect. So x2, y1. Is that okay? Now, if I want to find the length of AC, so I can say the points I'm looking for, AB in this case, would be equal to the length of, so AB squared, according to Pythagoras theorem, AB squared is equal to AC squared plus BC squared. Is that okay? Now, what's the length of AC? X, so x2 minus x1 all squared plus BC is BC, the length of BC minus y1. So AB squared is equal to x minus x1 all squared. Okay, this squared as well. So AB is equal to x2 root of, okay, x2 minus x1 all squared plus y2 minus y1 all squared. Is that okay? Now let's try a question and see how um, we can apply this practically. Find the length of the line joining the points P. P minus 1, 3, minus 1, minus 3, or let me use A, minus 1, minus 3, and then B to be equal to 4 and 9. 4,9, yeah. Yes, so what is this going to be? 4,9. It will be, okay, but let's do it together. AB will be, so what's going to be this? We can say this is the minus 1 is going to be x1, y1, and then this is going to be x2, y2. So this will be root of 4 minus minus 1, right? All squared plus 9 minus 2 bracket minus 3 all squared. So give us 5 squared plus 9 minus 3 gives me 12 squared. So AB is equal to 25 plus 144, right? So it implies that the length of AB is equal to root of 169. Is that okay? And what's the square of 169? 13. So AB is equal to 13. I like the fact that I added the unit. So you don't just write 13. You add units, right? Where the unit implies that it could be centimeters, meters, or whatever. But if you just say 13, you would be wrong. Okay? All right. So those things, those inscriptions are very, very important. Another question, then we can move to the next thing we have to do. What is the distance between the points P, 5, minus 6, and Q? So P, 5, minus 6, and Q, minus 2, 5. 5, minus 6, and minus 2, 5. Minus 5, minus 6. Okay. Master, get to work. All right. The coordinates again. P is what? Minus 6, and Q minus Q is what? Minus 2, 5. All right. So x1, y1, x2, y2. So we have PQ to be equal to root of 5 minus 2 all squared plus minus 6 minus 5. Oh, okay. Yeah, I'm doing the x first. 5 minus 2 minus 6 minus. Yeah, either ways is fine. So either ways, this order. So this is also fine. But let's finish this and solve the other one and see how it goes. So 5 minus 2 gives you 7 squared plus, this is what? 11 squared, 14. Yeah, so it still becomes the same as, okay, same as 11 squared, right? 1, 2, 1. So you get root of 170. which is 13.08 units, 038 units. And I'm sure if I had done the other changes, so I would have gotten the same value. You're okay with that? All right.